Okay, so here's your first video lesson. I'm just going to be going over the same presentation that we did in class. Okay, so let's start here. What is earth science? Earth science is the study of the earth and the universe around it. More importantly, the earth's role within the universe. It's broken into 4 different sub-sciences. We're going to start out our year with meteorology, which is the study of the atmosphere. Then we're going to move on to astronomy, the study of the universe beyond the earth and including the earth. Then we move into geology, which is most of our year, the study of the origin, history, processes, and structure of the earth. And last we'll do oceanography, the study of the oceans. So the definition of science. Science is the process of gathering knowledge about the natural world. Its goal is to explain how and why. The scientific method is a series of steps used to solve a problem. There are a set series of steps, but there is no set way to go through the steps. The only one that is set would be the first step, which is to ask a question, and it has to be a testable question and should not be very broad or wide. So you were asked in class, which of these scientific questions is a good question? Number 1 is not a good question because it's measuring feelings. Number 2 is a good testable question, and yes, plants do move to get their food. The third one is asking you to measure intelligence. Intelligence is really not something that is measurable. Observations are gathered through the senses: touch, smell, taste, only if it's safe, sight. Okay, a hypothesis is a possible explanation or an answer based on research. It is not just a guess. Research must first be done. It's also written if, followed by the independent variable, then followed by the dependent variable, and it must be testable. So what's wrong with this hypothesis? If a person drinks a Monster each morning, then they will feel much more energetic during the day. Again, it's looking at feelings, which is not really something that you can test, not accurately, and so it is not a very good hypothesis. You experiment to test your hypothesis. There are lots of different components that make up the experimental design. A control is a setup that you do not change or alter and is used for the basis of comparison. Not every experiment has a control. Constants, however, are the same in every setup to make sure that you're only testing one thing. Constants are what make the experiment valid. Your independent variable is what you're testing. It's also what follows the if in your hypothesis. The dependent variable is actually what you're measuring. It's what's changed by the IV. And it is the second part following then in your hypothesis. So let's practice. Laundry detergent A claims to be the best on grass stains. I want to see if it's true. I'm testing it against 2 other brands that claim the same thing. So my IV, what am I testing? Laundry detergent A. What is my DV? What am I measuring? How well it gets out the grass stain. Constants, and there are many. Same temperature of water, same amount of water, same type of stain, same level of stain. It has to be the same washer, the same amount of detergent, and so on. What would be a good hypothesis? If laundry detergent A is used, then the grass stains will be removed. So you record and analyze your results through data. It's important to know that even a graph can tell you the IV or the DV. The IV is always going to be on the x-axis, as shown here, and the DV is going to always be on the y-axis. So even a graph can tell you what the independent and dependent variables are. Then you look at your data and you form a conclusion. What did you learn? Was your hypothesis supported or proven wrong? Where will you go next? Then you share or communicate your results with other scientists so that they do not waste time and money doing exactly what you have done. You always repeat an experiment. A good experiment is never just done once. You've proven nothing. So at your level, at least 3 times, in real science, hundreds to thousands. A model is what you use when you cannot show the real thing. Atoms have not been seen, so you must show a model to give the idea of how you believe the atom works. Or maybe the solar system. You can't put it in someone's hands, but you can put a model in their hands to explain it. This bottom right picture shows a concept, the magnetosphere. The magnetic field cannot be seen, but instead is represented through a model. A mathematical model would be a map. You can't put this whole region in someone's hands, but you can scale it down mathematically and put the map in someone's hands. A theory is an explanation that's consistent with many tests and observations. It is not a random guess. A theory is accepted as true among scientists. It just is used when you can't fully see it. For example, we've never seen a universe being formed, so the Big Bang Theory attempts to explain how. But the Big Bang Theory is based on the idea that quasars, the farthest object out in the universe, are also the oldest, and that what's in the center of the universe is the youngest, and the idea that everything is expanding outwardly from the center, showing that there must have been some kind of explosion in the middle. A law is when it can be proven as always true. Whoops. So, speed of gravity is a law. Evolution, theory, inertia is a law. Big Bang is a theory. Okay, the metric system is now called the International System of Units, or capital S, capital I. It's used in science because it's considered to be most precise. It's based on the powers of 10. The prefix milli means 1 out of 1,000. Centi means 1 out of 100. Deci means 1 out of 10. So if you had a meter stick, you would have 10 decimeters, and in each decimeter there would be 10 centimeters, and in each centimeter there would be 10 millimeters. Kilometer means that you took that meter stick, laid down 1,000 of them in a straight line, and that would be a kilometer. So length is measured in meters. It can be centimeters, millimeters, kilometers. Which unit would you use for these? The length of a book, centimeters. From school to home, kilometers. An eraser on a pencil, millimeters. Volume is defined as the amount of space an object takes up. Think of a balloon before you blow it up. Its volume is very small. Each breath of air increases the volume. It's taking up more and more space. A graduated cylinder is what you use to find the volume of a liquid or an object that is irregular, such as a rock or a marble. The meniscus is the curve that we see here that exists in a graduated cylinder and should always be measured from the bottom. If it is a regular solid, like a room or a desk, you would do length times width times height. So, let's practice really quickly. Imagine that this is a rock. My graduated cylinder, I get it out. Whoops, sorry for my drawing. Then I put in 10 milliliters of water. It's hard to draw with a mouse. Then I put the rock inside my graduated cylinder. The water rises up to 13 milliliters. So then the volume of my rock equals the difference between 10 and 13, which is 3 milliliters. or, because it's a solid, cubic centimeters. They are interchangeable. Okay, mass. The amount of matter in an object. How much stuff is in there? It's measured in grams. We use today a digital balance. However, in this picture, an old school would use the triple beam balance. Weight is the amount of gravity pulling on an object. It is not the same as mass, although a lot of people interchange them. If you were to be taken to the moon, your weight would change, but your mass wouldn't. You would still be the same size. Weight is measured in newtons. Density, what you should really know, is mass divided by volume. Mass per unit volume, mass over volume. They all mean the same thing. Fresh water, meaning no salt, has a density of 1. Anything with a density more than 1 will sink. Anything with a density less than 1 will float. Temperature, our last part of measurement. The Kelvin scale is used for extreme temperature areas. Fahrenheit is only used in the United States. 212 is boiling and 32 is freezing. Celsius is used in science and in every other country. It's 100 is boiling and 0 is freezing. So, which scale would you use? First, to record temperature from planet Venus, Kelvin. To record temperatures from Antarctica versus the equator to prove global warming trends, because it's science, you'd use Celsius. To report local temperature from day to day in Virginia Beach, you're in the United States, you'd use Fahrenheit. Okay, make sure that you study for your test. If you're an auditory learner, you need to listen to this several times. Visual learner, you may want to watch this several times. And all the kinesthetic learners, it's time to make some flashcards. See you guys next class.